Welcome to May's Leetcode Challenge. Today's problem is super palindromes. Let's say a positive integer is a super palindrome if it is a palindrome, meaning it's the same forwards and backwards, and is also a square of a palindrome. Now, given two positive integers, left and right, represented as strings, return the number of super palindrome integers in the inclusive range from left to right. For example, if we're given 4 to 1,000, there is going to be 4 super palindromes. Notice how the square root of each one of these is going to also be a palindrome. So here 2, I guess that counts as a palindrome. 3, 11 is a palindrome, and this, I actually don't know what that is. 1 to 1 maybe? No, 1 to, I don't know. But whatever this is, the square root of this is a palindrome as well. Okay, so what we want to take advantage of here is there's actually not that many super palindromes. Even in this huge range from 1 to the 10 to the 18th power, there's really not going to be that many super palindromes that we can calculate. So what we'll do is first calculate all the possible super palindromes, Now to begin, we might start with saying, okay, well, let's make some sort of list and say for I in range of 1 through 10 to the 18th power, but we don't actually need to do it to the 18th power. We can do it to the 9th because we will be appending to this right here, I to the square. So we know it's going to be within the range right here. We don't have to do it all the way to the 9th power. But this isn't going to work, and the reason for that is a little bit confusing. But basically, I think they just set the constraint so that even running 1 to the 10 to the 9th power is too long. Time limit exceeded. So even this right here is not going to work. So what can we do then? We know that it needs to be a square, right? But we also know this number that we generate to begin with, this I, needs to be a palindrome, right? So what we might be able to do is say for number 12, right? What we'll do is say, okay, well, there's 2 possible palindromes we can calculate here. We can calculate 1 to 1, and we can also do 1 to 2, 1. These are 2 palindromes that we can make with this number. Same with like 13, say, or any number for that matter, like 1, 3, 4. We have 1, 3, 4, and then 3, 1, and then 1, 3, 4, 4, 3, 1, right? And what we'll do is get these numbers that we generate and square them, and that's going to be some of the candidates that we can make and put them into this list here. So let's start off by doing that. And if we do that, actually, we don't need to do it to the 9th power. We can do it, I think, up to the 5th, I believe. Okay, so how will we do this? Well, let's first generate our numbers, and I'm going to call it odd and even. The reason being, it's going to be an odd number of digits or an even number of digits, right? So what we can do then is, let's see here, I'm going to convert it to an integer, and we're going to say get the string of I plus string of I, but get rid of the first character. Is that right? And we also need to reverse it, right? So we need to reverse that. Let's see. We can do that by just saying it like this. And then we got to square it by 2. Now let's do the same thing here, but with the string I, we will add it to string I again, but reverse it. And again, we will square it by 2. So let's see, string I, that's right, this. So let me first make sure this even works. What we'll do is we'll say, like, look, if odd equals these are integers, so string odd equals string odd reversed, it's a palindrome. So we're going to add the odd to nums. And the same thing here, if string even is equal to string even reversed, then we'll add that. Now let me make sure this works. I may have missed something, so let's see. Okay, so that looks like it's working. I can't be completely sure yet, but we can see that it is possible that we'll have some repeating numbers here. And it might not be sorted either because we're doing odd and even digits. So what we'll do to take care of that, we will let's see. We'll make it into a set first. Make it back into a list, and then we'll sort it. Okay, now all we need to do is for all the numbers here in nums, we'll add it to an output. We'll say if this number is, let's see, int left, this is in bounds of the left side, and it's in bounds of the right side. Then we're going to append it to our output, and then we'll just return the length of this output. So let's make sure this works. Okay, that looks like it's working. But one thing to note is this actually won't work. And the reason for that is every single test case that we run, it runs this whole thing again and again. So to kind of avoid that and save some time, what we'll do is actually put it on top here in the class. And this will kind of guarantee that this runs just once. And afterward, we don't need to worry about running it again and again. So this will become a self variable. So that would mean I have to go self.nums here. Let's make sure that works one more time. Okay, it still works. Let's go ahead and submit that. And there you go, accepted. So time complexity, I actually don't know. It's like log of n times n to the something power, possibly. But it's really confusing because I do all sorts of weird things. So I'm actually not entirely sure what the time complexity is. On top of that, I had to kind of put this up in here to get this to work. If I, just did it normally and put it here, for some reason it doesn't work. And it's probably because it's running this algorithm again and again. Even though it works, like since we're running this every single time, I guess it kind of fails the test cases, which is unfortunate because my logic is sound. It's just the way that it's set up won't allow it to complete in time, so that's annoying. Alright, well, I hope that helps. Thanks for watching my channel. Remember, do not trust me, I know nothing.